Hi, everyone. Welcome to Riot's Lunch and Learn series. My name is Caroline Griffin. I am Riot's Director of Operations, and I am super excited to have Chris Gamble here with us today from Golioth to talk about the 12 layers of IoT, everything you need to build your IoT product. We are going to have a great crowd with us today. Just a couple of reminders before we get started. This session is being recorded. It will be posted to Riot's YouTube channel and then shared out to the meetup group where you registered for this event. If you have any questions throughout the presentation, please do put those in the chat box. The Golioth team will be actively monitoring that. We'll also have room at the end if you want to unmute yourself and ask some questions then. And then the last reminder is the best way to view this presentation is in speaker view. So if you go up top and hit view and hit speaker view, that'll give you a nice big view of Chris's presentation and then a little box of him on this side. But without further ado, thanks for being here, and I'll hand it over to Chris.
All right, thanks, Caroline. Hi, everyone. My name is Chris Gamble. We're going to be talking about IoT today. So I have a little bit of this. I'm getting used to this new software here too, so sorry about that. A little bit about me. So I've been doing hardware about 20 years. I am the developer relations lead at Golioth. We actually are a member of Riot, and we love all the stuff that Riot does, the programming and the events and stuff like that. My background, I've worked at places like ABB and Keithley and Samsung, Hologram. So just kind of all over the place in terms of different hardware companies, and actually got into microcontrollers and then IoT kind of later in my career. And most recently in the past 3 years, I've been doing consulting stuff. So I saw a lot of clients who came to me and said, we need to design this system. Like I said, most recently I'm at Golioth. It's a device management platform. My coworker, Mike Stish, is here as well. Mike is our developer relations engineer, and he's going to be in the chat. If you have any questions, you can, of course, ask him as well. Like I said, one of the things that I've been kind of seeing throughout my career is just that IoT services overall are not straightforward. The genesis of this presentation has been trying to map this out, actually, both when I was as a consultant and then coming into Golioth and trying to figure out kind of what's out there, what can you buy, what do you need to build yourself? And really the big thing here is the long-term effects of making upfront choices. So in the case of, some of these layers that you might choose at the beginning, they can have very significant effects further down the line, especially the difference between prototyping and development, right? So what might be a really, really great prototyping platform could end up biting you later when you're in deployment and you're like, great, I've got to 100 devices. Now I need to get to 100, 1,000, or to 1,000, 10,000, a million devices, and kind of things can change radically. Now, not everybody thinks that they're going to get to 1 million devices on the first day, but kind of understanding that upfront, that's kind of what we're talking about here. Like I said, most of the platforms that it's not necessarily that the prototyping platforms aren't going to be good for scaling, but it's just you need to understand the differences. So some of the things we're going to be talking about here today are the trade-offs between what you can buy, and that would be kind of buying into a platform, and then how much you can DIY. A good outcome for you in this training would be being able to understand these 12 layers, at least how I define them. There's going to be probably some differences you have in your mind, but understanding the different layers that are out there, and then being able to identify them with a new service offering, maybe one that's not even on the market yet, and saying, is this going to fit all of the needs that I have and that I might have in the future, right? That's kind of what we're talking about here today. So this is what created the genesis of all this, is this chart. I started, like I said, I was starting it at Golioth. I wanted to map all this stuff out, and I was like, well, how do we compare if I go with one provider on another, including with Golioth, the people I'm working for? And so I made this chart, and this is actually a much scaled down version of it. This had a lot more data on it, but just to kind of show you some of the mapping of different platforms that are out there, what they have available, and kind of where things are in the system. It was kind of just a visual reminder. So we're going to go through, some of these are actually case studies at the end, but what we're really looking at here is these columns. Each of these columns is the layer. I guess I should have maybe turned it on the side, but one thing that is actually absent from this is you'll notice that I don't have anything about here where I'm just going to AWS and building stuff myself, or Azure or Google Cloud, or building things up from scratch. I'm calling that actually the DIY, even though it is buying solutions from a cloud provider. And there is a differentiation between maybe an AWS and an AWS IoT, But in all of these cases, these are, if you were just going to go and start from scratch with a web team and buy a bunch of server time from an AWS or an Azure, I would call that more DIY. And that's going to be some of the comparisons that we're going to be making here. So let's dig into the actual layers, because that's what we're here for. So the first layer is hardware, right? So if you have an IoT device, the T of IoT is thing. You need to have a hardware thing. And this is ultimately what is going to determine the specifications of the thing you're building. I'm showing dev boards here. Obviously, these would not be the things that you put into your product, but these are just very easily accessible photos here. And ultimately, this is what is interfaced into the real world. So some of the examples that might be out there are some custom stuff. So that's what I used to do as a hardware consultant. So I built custom hardware. You might buy something off the shelf. So this blue thing in the middle here is actually a layered bridge, cellular bridge. You can buy directly from there. I have another one called, I just call it migration based. So people like Particle, they have a dev board, which you can then maybe buy a SOM or module you solder down to future stuff. And then generally as a overall topic, I wanted to talk about buying hardware directly through a cloud provider. This is a vertically integrated solution. And the most vertically integrated solutions, I think, actually are an interesting use case. We'll be talking about one of them as a case study at the end. Let's talk about some of the risks, though. So if you're doing DIY, obviously, it's expensive to hire someone to just go and design all your hardware for you. There's a lot of pitfalls there. If you don't get it right, there might be multiple revisions. And if you're paying attention to the chip shortage, this is a thing that I have been weeping over many nights. 2021 and 22 has been a tough time for sourcing parts. And so you could just really get in a tough place here. If you're going to buy a solution, maybe from a vertical provider, the switching costs are really high. So you get all the way to you say you have 1,000 devices. Well, now you say on that 1,001st device, I'm actually going to switch to a whole different hardware platform. That is like blowing up your entire system, and that's bad. Also, if you are doing that vertical solution, you're kind of locked into certain ways of doing things. It's going to make it easier to get started, but it's going to lock you into certain layers that we're talking about here as well. And finally, the sourcing issues, those also exist for some of the hardware providers that are out there that include hardware as part of their platform. Some of those are also having sourcing issues. We're all feeling it. It sucks for everyone. So next layer is device firmware. And so this is an interesting one. If you don't have much of a background in kind of lower level firmware, you can run things bare metal, where you're just writing code directly. You might be running assembly code or even C code directly on the device as a super loop. But then you start to move up a little bit and you might be running a real-time operating system. That's really where I start to define the device firmware overview, or the device firmware level. So you might be running an operating system, and then you're going to run code on top of that operating system as well. This is sometimes just there's an open source one we'll be talking about here. There's a couple open source ones, but then there's also vendor offered ones. But basically, it is something that's running on your device that I then say is separate from the next layer, which we'll talk about. And the things you want to be thinking about here is they might be locked to your vendor solution as well. So just another thing to think about lock in there as well. So some of the examples we talk about here, FreeRTOS is a very, very popular one, probably the most popular in the market. Zephyr is the one that we use at Golioth that we like. It's an open source one. ThreadX is another one that's been in the market a long time. Particle OS is actually built on top of FreeRTOS, but that's like another layer of vendor integration there. And then there's, of course, you could always write your own real-time operating system. I do not recommend it, but some people still do it anyways. And so keep FreeRTOS and ThreadX in your mind here, because actually, let's just start with that as a risk. On the buy side, some RTOSs are owned by cloud companies. ThreadX is actually now owned by Azure. FreeRTOS is now owned by AWS. They don't stop you from doing other stuff with them, but some of their supported paths are directed towards those cloud companies. So that's just a potential risk there. Just to do the other one on the buy side here, if you're in a particular operating system, basically you're at the mercy of that operating system. So if you want to add a new feature, you have to kind of deal with that operating system itself. On the DIY side, building from the ground up is that's crazy. And just each additional feature is tough to add. All right, device application. Now this is the code that's running now on top of that layer. So on top of that real-time operating system. So basically, this is your business logic. This is, you want to blink an LED, you turn it on, you turn it off, right? That's usually running in the application level code. Depending on how you define your system, it doesn't have to be at that level, right? You could combine these two together, but keeping them separate there are a lot of benefits to that sort of thing. And if you're doing DIY, it's going to be dependent on how you do that sort of thing. If you do it right, you can actually make it portable, and you can have it so that you target different hardware devices and different network interfaces. But this is really going to be kind of how you define things. Some examples here, Particle Web IDE, basically this is running Arduino code on top of the Particle OS, right? So Particle OS is that device firmware layer. Then the Arduino IDE piece of it, the user code, is the device application. Also, Toit is another one that's out there. Basically, they almost run containerized things on top of the ESP32. And it's kind of hard to see here, but you would only write just some software apps on top of that. And so from an update perspective, they actually see some really cool benefits from doing that from an update perspective. Some of the risk here, just you're at a higher level of abstraction. You're not going to see as much stuff under the hood. As long as everything's working under the hood, you should be fine with it. And then it's possible that if you're at a higher level of abstraction, you might end up using more resources, and you might drain your batteries a little bit quicker. And then finally, if you are doing a DIY thing, you just need to make sure you're kind of doing at the right level. And so if you don't have experience in this, it can be tough. All right, layer 4. We are a third of the way done, quarter of the way done. We're into the third. Connectivity and security. Now this security was actually added last minute. I meant to take that off there. Sorry about that. We're just saying connectivity here. And this is because I was talking about cellular devices. That chart that I drew, I probably couldn't read it, but it was all cellular devices. And so when you're doing cellular, or if you're doing other LPWAN type things like maybe LoRa or Sigfox, if you're in a bad spot right now, you need to deal with a network provider there, right? If you have a Wi-Fi device, you're kind of just connected there, and so you're probably not thinking about it as much. But if you are in if you're working cellular, we're just going to talk about the cellular space right now, then you need to then have a connectivity layer there, and some of the providers actually layer that in with their service offering, and so that's what we're talking about here. And so some of the examples here, if you're going out and buying it yourself, you might go to a hologram. If you're with a Blues Wireless, it might actually be included with your services. This is a little bit different in terms of how I split the risk side of things. So if you go to a separate provider, the risks are an additional layer of management, and less synchronization. So it's not actually in your console. It's just in the, you have to go to a separate website, a separate, maybe your separate API, talking to that sort of thing. But if you're taking advantage of a totally integrated provider, the cellular is part of the service offering, you might be limited to what their offering is, and you might not be able to cost optimize. So again, when you think about going from 1 device to 100 devices to 1,000 devices, you might not care so much about data. But when you get to 1 million devices and you're sending gigabytes of data a day, your operations people are going to be like, well, what can we do to optimize that cost? And if you're completely locked in at that layer, then you're going to say, we can only pay what they tell us we have to pay. And that's just a decision you need to know upfront, that you might be asked that later. All right, now we start talking about into the cloud side of things, right? So far we've built a hardware device, it's got firmware on it, it's got an application on top of that, it might be connecting over cellular up to the cloud. And now we have a cloud interface. So now this is somewhere between the cloud interface and your device itself. And I listed this as configuration/state. So I think each and every IoT device out there is going to want to have some kind of way to configure the device. So you want to know that you have a setting that says this thing is updating every 30 seconds, and the LED is set to on when it is updating, and it's sending back battery data and things like that. But it's this push and pull from the cloud side down to the device side and back and forth. And also there is a concept of state and what is the actual device currently at. So even if I say, all right, device, you were updating every 30 seconds, I want you to go and update every 20 seconds instead, there's a time lag between when you set that from the cloud and from when your device actually receives it and starts doing that sort of thing. And so you need to actually have some kind of management around that piece. The key thing is you're going to have variables on both the cloud side and the device side, and you're going to broker when something happens on the remote device and how the cloud reads that state as a result of that change. Sometimes this is referred to as digital twin. There are some other things out there, but basically we want to make sure that we can send and receive messages to and from the device. They're kind of time invariant. So you just want to know what the latest state is. It doesn't really matter when it's updated because you might not have knowledge of how that channel has been transmitted the messages. And finally, you want to have some kind of resilience in that channel as well. So if I say from the cloud, hey, change your update rate, that even if this device is offline for the next hour, then when it does come online, it finally says, oh, I have a new message, and it goes and gets that message. And then finally it's there. So it's kind of a queuing kind of thing as well. So some of the examples we have for this, so Golioth has a concept called LateDB state. This is a management, this is built into the management console, but really it's a database that holds the state of a device. And then AWS IoT Core Device Shadow does the same kind of thing using MQTT and some queuing locally. So if you have a device out in the field, it'll go and grab its latest thing, even if it's been offline for a while. Some of the risks here. So if you are doing this DIY, or if your platform doesn't have it, you basically building your own is non-trivial, right? So basically it's not just like, oh, I have a database here. It's understanding all of those other pieces about buffering and understanding if a message has been received. And basically, if you do go and build it yourself, say you say, I don't like the services that are out there, I'm going to go build it myself on a cloud provider. Well, then you have that maintenance and code base overhead. And that's just something that's a common theme that's going to come up as we do more and more, talk about more and more of the cloud layers here. From the buy side, right, if you put all of your device intelligence into a vendor optimized system, you're basically locked into that. And then you might not have as much flexibility as you might need. And then if you kind of get to the point where you're like, well, I just need this one other feature, and your vendor provider doesn't have that, then you might have to go and build an entire infrastructure around anyways, which can be difficult, or do a bunch of workarounds. Whew, all right. This is always so weird doing a presentation like this, and there's just, I see Mike's face, which is great. He's smiling at some of my jokes, but I can't see anyone else's face. So hello, everyone. Thank you again for coming. All right, so we're on layer 6. We're almost at the halfway mark. And we're talking about time series data. So now this is different than state-based data, because this is now, most IoT systems, when I think about an IoT system, I think about a temperature sensor out in a field. I know that's a completely reductive thing, but that's just like my mental model of it. It's just pinging temperature data every once in a while. And when you're doing sensor data, such as a temperature sensor, which is a very common kind of model around IoT, you want to know not just what the temperature is, but when it's happened. And so this is kind of separating that out. You could send that same temperature over a state-based thing, saying my last measured temperature was 25 degrees C. That's great. But you probably want to know the history of all of the other measurements that device has taken, not just the 25 C at the most recent thing. I want to know what it's been over time. And basically, when you go and start to see a chart of an IoT device's metrics or sensor data over time, that is likely time series data. So that's kind of the pairing that I do. I see a line chart. I'm like, okay, this is probably time series data, because on the x-axis there is time. That is a key point there. So you can see that how it's been changing. I think this is, like I said, a very common aspect, and something that a lot of people want to do. It's not always codified into different services. Sometimes it's actually kind of back calculated. So sometimes people will have state services. So they say, well, my latest thing is my latest temperature is 25, but then something has to be watching that on a regular basis and saying, what was the last temperature? What was the last temperature? And then it sees a change and it says, oh, at 2:30 p.m. it changed from 25 to 26. So just thinking about like how this is all built in here. So some examples of this, Adafruit.io has a backend time series data processing of this sort of thing. So this is another one. That's Adafruit.io is a visualization platform mostly, and that's actually on that chart that I did initially. And then Azure, of course, as well. Azure IoT also has a time series insights thing, and really, you'll see this in a lot of different places, but and I think this is actually one of the most common components of a lot of IoT platform systems, basically. So some of the risks, if you go your own route, basically, it might not be hard to do this for one, right? If you say you're setting up some scripting or something like that, but you try to start scaling to 10,000 devices and managing all that, it starts to become a DevOps nightmare, basically. DevOps nightmare is another theme you'll start to hear is usually you think scripting and you think DevOps nightmare, because it's not as hard for 100 devices, but 10,000 devices, 1 million devices, it gets really, really messy. If you are building it yourself on an AWS or an Azure or whatever, and again, I want to separate out I talked about Azure, I showed Azure. Azure IoT is different than Azure, the cloud provider. So I'm saying going to build your own thing with some raw Azure resources instead of Azure IoT. That's great. You can do that. You might have some capabilities to do that sort of thing. But then the costs can start to really spin up because of that, right? Because you're using resources, because it's a per transaction type of thing. And so just kind of keeping costs in mind here. If you're on the buy side, so using a platform now that has a time series data thing built in, you might be rate limited. So you might be only be able to update once every 10 seconds, right? You only can take a reading every 10 seconds. And you say, oh, well, I need to go to every 10th of a second, every 1 second. Well, that actually might bump you up in a higher tier as well. So again, that might impact your costs. And finally, because of how data is stored in platforms as well, say you need to keep this data, say you want to see that line chart, not from just yesterday, but you want to see the temperature data for that sensor from a year ago. Well, someone's got to store that data somewhere. And so if you're moving all that data around, your platform might say, well, we only keep this for 30 days. You got to move it out somewhere else. And there could be some costs as well in that movement. So just another thing to keep in mind. All right, quick sip of tea. We're about 20 minutes in here. All right, so device management. Basically, as your device fleet grows, you need to know kind of what's out there, where it's deployed, and how it's doing. That's really how I would define device management. You see a display of all your devices, could be visualized in a lot of different ways. But if you think about it, even just as effectively a list of all the devices that are out there, maybe filterable, or maybe you could search on different aspects of it. You need to know what each device is doing out there. And sometimes you have ways to kind of slice and dice the data, and that's really useful because you might want to say, oh, well, only show me things from site 43, and on site 43, only show me the things that have the newest firmware version running on them because I have a partial deployment field out there. Well, that's actually a really important thing to be able to do, especially if you're troubleshooting, right? So troubleshooting is a big piece of that. But there's a lot of tooling that happens under the hood to make that possible, right? You need to be able to not only see all the devices that are there, you need to be able to visualize it, you need to be able to slice and dice. And there's a bunch of things that are built into that sort of thing. And so cloud providers such as Blues Wireless's Note Hub interface, that is a management interface for note card devices that Blues makes. And so you can go and see what are the latest status of all these things. And they actually have some device metrics that are built in as well. Blink, which is actually an app-based thing, and it started with Bluetooth. I think it's into Wi-Fi now as well, and maybe one or two other things as well. But basically, it's it has a management aspect as well, and basically you can go and see the status of reported in devices. The DIY aspect, I have to say, if there's one thing I say do not do a DIY on, it is this. I think that this is the kind of thing where if you're in a platform and say you're deploying 1,000 devices for someone, and I say this actually from I tried doing this. I tried thinking like, oh, well, I could just like have 100 or 1,000 devices in the field, and I could just like run a script to go and scan through all the devices that are out there. Maybe I have like a list of all the devices that are out there, and I can just go and pull off the ID of the one that I need, and then look at the specifics of that one device. That is really tough to do. You can do it programmatically, but it's really tough to do on a recurring basis in a consistent way. And then if you really think about it, scaling it out to like an operations group. So most of the time, you as the product developer are not going to be the person that's troubleshooting an individual device. It might be someone who's actually in the field, who's looking right at the device. They want to be able to see it. They want to be able to update it. They want to be able to see if this device is online and connecting. Having some kind of graphical UI element there to give a visualization of what that device is doing and all of its characteristics is really, really important. And then I also have differentiation on here. It's not like you're going to, you're probably not going to add a ton of differentiation internal to a company. So I think this is definitely one that's worth buying. Of course, the downside on a buying thing is always lock-in. All of these things, I think lock-in could probably be a thing for all of these, but I would say also the scale of deployment could also be a potential problematic thing here. Okay, device firmware update. So this is called a couple different things here. This is sometimes also called over-the-air updates, but this is basically when you need to send an update out to your fleet of devices. How do you do it? We call it device firmware update. It's called a lot of different things out there. But the big thing is you need to be able to remotely update devices that are out there, and you need to know that they've been properly updated, right? So it's not just the I have a new file that I want all these devices to grab. I also I need to be able to manage which devices are getting the updates and how how are these things being rolled out. And so the last point I have on here is that it's intertwined with device management. And so you might see that when I talked about slicing and dicing your fleet down to maybe a subset of devices, you see that you're on site 43 and you see that you have 100 devices there, but you only want 10 of them to get the update. Well, you could slice and dice and say, okay, only these 10 are eligible for this update, but you need, again, some kind of management system to do that sort of thing. One other thing that's in here is that if you remember back to layers 2 and 3, so layer 2 was the device firmware. So that was like the real-time operating system. And then there was the device application. That was layer 3. Some things like Toit, they go and they only update the application, and all of the firmware piece stays the same. And that is kind of like a containerized model, and that can be useful. Actually, Particle also does that same sort of thing, that most of the time you're only updating the application, you're not updating all of the firmware piece underneath it. Other systems like Golioth and others out there, basically they go and do a wholesale update of all of the firmware and the application at the same time. And there's pluses and minuses to each of them. Some of the examples that we have here, so I show the Particle IO OTA firmware update. So that's one of the systems that's out there. And then AWS IoT also has a service called Lens, where they use their MQTT brokers and basically some buckets. So basically the IoT team at AWS built this on top of many of the AWS primitives. And basically they have a system set up so that you can be notified when there's a new firmware available, and then you can go and grab that and then validate it back through the MQTT system. Some of the DIY versus buy risks here. One of the things that I always came up against is that I kind of thought of the firmware update piece later in the process, like, oh, that's a thing I'll get to later, and usually by the time you need it in the field, it's much too late, right? You have to then go and refactor a lot of your code, and there might be some other things that you just weren't thinking about, some of the resources that are required around it. And so this is another one where I had thought, okay, I could go and write a script to scan those 100 or 1,000 devices that are out there and just say, oh, hey, 100 or 1,000 devices, there is a new firmware available, everybody goes and gets it. But then there's no tooling around that. There's no validation that the firmware has been updated and applied. And it actually pushes a lot of the burden of the intelligence down onto the device itself. So that's really a tough thing about if you're kind of DIYing this sort of thing. You could very easily go set up an S3 bucket and say, when they're just keep every month, every week, see if there's a new version. Go check that new version. Is there a new version? And when there is, just go and download it at your own convenience. But then all of the intelligence is on the device side, and there's really no talkback. So if it then goes and bricks itself, you have a very expensive piece of fiberglass and silicon in the field that doesn't do anything anymore. On the buy side risks, sometimes there's quotas, right? So this is an expensive operation. If you're deploying a firmware package to hundreds or thousands of millions of devices, it can be just a lot of data, and it can be an expensive part of a platform. And it does require some deeper integration with the layer 2. I misspelled firmware here. Sorry about that. It does require some deeper integration. So you really need to be thinking about what is the cloud doing, but then also what is the device doing. So you might need to have some more of those hooks on the device side. You might need to be writing some of those. If you're not using a fully verticalized solution, then that means you are writing that device firmware stuff yourself, and you need to understand kind of the implications of going out and grabbing that firmware update and what it's going to do to your system, and how do you recover from errors and if things go wrong. All right, layer 9 is cloud interoperability. So this is basically, now you're using a cloud, you've got your data somewhere in the cloud, maybe at a service provider, maybe it's stuff that you built yourself, but now your client, say you're a hardware firmware consultant, as I used to be, and they say, you know what, we were using cloud provider A, but now we need to use cloud provider B. And that can be very problematic, because if your tooling is all built around just talking to cloud A, then it can be kind of a record scratch, and you have to stop everything and then go and start working and having things connect to cloud B. And so basically what happens on the platform side, if you are buying if you are paying for a platform, one of the benefits there is that there is interoperability. So you're maybe sending data to this intermediate platform, but then you can export it to where your cloud teams are, like an AWS, like an Azure, like a GCP, and being able to interface to these different things. One thing that's nice about it is that we always talk about on the device side, almost all the devices that Golioth use are constrained devices. So microcontrollers instead of Linux devices. Linux devices can kind of take on more of that management and intelligence aspect. But when you're a constrained device, you have very few resources to then go and switch and change where you might be talking to different things. And you probably aren't talking directly to many of these cloud providers in the same way that they expected to be talked to. So for example, if you're talking over HTTP to an AWS server just to get to a database or something like that, it might be that is a 6 kilobyte packet in order to send a single packet, just because of all the required headers and things that are included in there, and security and all of the things that kind of layer up in there. That makes it just a difficult thing to do from a constrained device. And so now if you're going from a constrained device to a platform, now the platform is on the cloud itself. It knows how to talk down to a constrained device, but then it can talk out to other servers easily because it knows how to talk HTTP, and it's less resource constrained. So some examples of this, Golioth has one called output stream. So basically you're able to send events out to different things like AWS. These are all actually queues. So GCP output, AWS, and Azure, these are all like queue inputs basically, so that you don't miss any messages. And then also visualization streams. We'll talk about that a little bit later. And then the Blues Wireless Node Hub also has similar things that are basically sending data out to the cloud providers that you want. So some of the DIY risks here is trying to do this from the device basically is very tough on a resource constrained device. And if you are buying it, it's another layer of software management basically. So this is just another thing to think about. Systems that are closer to using raw web processing. So like I said, talking between servers, there might be more cloud side code. So again, as a hardware and firmware developer, I kind of thought about stuff on the other side of the interface, right, between device and cloud. And I just remember thinking, like, I don't even know, like, what do I do, like write Python or something like that? I mean, there are cloud engineers out there that understand all this stuff, and you can do it in a lot of different ways. But as a someone coming from the hardware side, I had no kind of visibility into this, and so it's nice to be able to just kind of push it out. So if I'm working with the cloud team, I can just push it out to them through these different interfaces. All right, deployment flexibility. How are we doing on time? We're about halfway done here.
You're all
deployment flex. Okay, great. I wanted to just make sure that we get to the case studies, because I think that's where the rubber hits the road on this stuff as well. So deployment flexibility. This is probably the least thought of, but the most important. And so again, when I think about making something that's going to get to 1 million devices, right? It's hard to think about when you're on a breadboard, you're prototyping your first thing, you're talking to sensors, whatever. But some of those devices, some of those products that you're building could get to 1 million devices. You may want them to get to 1 million devices. And I think the constraints around that become completely different from that person that's doing the breadboarding and the small scale prototyping at the beginning. So you just need to think about it at the beginning. So one thing that I think about is, can you expand as much as you want? So the answer might be yes, right? A lot of service providers are very willing to keep scaling your services as you need. They are able to keep offering you more resources, and the prices will go up. But often the cost expectations are a little bit different there. And so that's really where you need to start thinking about it. It's like, if I get to the point where I have 1 million devices, am I going to be able to use the same platform and system as when I had 100 devices? And often the answer is no. And the reason I know this is because I've been hired to design out platforms before. And that was where I started to run into some of these IoT problems as well. So someone came in and said, hey, we're using this platform. We don't think it's going to scale for us. Can you go and restart from scratch and now go and build your own hardware, build your own firmware, build everything from scratch all the way up? And this is a common thing where companies run into this, the roadblock itself might be different between different companies, but when they finally say, you know what, this one platform that we've been using, it's just not going to work into the future, then you're basically starting from scratch. And that is painful. That's really painful from a cost perspective, from a time perspective. And if you are thinking that you're going to get to this kind of million plus device hyperscale sort of thing, it's just thinking about it at the beginning is good. So there are some options out there that actually allow this sort of thing for flexibility. And so one example is Clearblade. Basically, they will sell you a on-prem offering. And so what that happens then is basically an enterprise offering rather is you can basically buy a license where you're running it on your own servers or you're running it on their servers, but they're managing it. And Golioth also has an extended / enterprise edition as well, basically modern on-prem. So thinking about like being able to take all the things that you've already been using, that you've been prototyping with, you've been building with, and now, okay, but I actually want to scale this myself. I need to run this in-house. I need to run this behind a firewall. I need to run this on oil derrick. All of those things are possible, but you can actually buy a license to it and run it yourself. Some of them have this. I should also say some of the platforms that are out there, some of this is an unstated, like they'll do it. They don't list it on their website. And that's an important thing to know. But I would say, at the very least, if you think there's any chance that you will get to 1 million devices, I would say go and look for that portion of the platform that you're choosing and make sure that there's some kind of scaling. So like talk to them, talk to a salesperson, say, what happens if I get to 1 million devices? What does it look like? How do things change? And what ends up happening here? Now, obviously some risks here. So the DIY in this case is your manager said, you know what, we're pulling the trigger. We're going to go and build everything from scratch again. Well, that is the risk, right? Now you're starting over from scratch. Not only do you need to go and get all of those different raw elements from a cloud provider, maybe even in-house cloud teams, that sort of thing. Maybe you're going to build your own hardware. You're starting everything from scratch. And that is a huge risk, but sometimes it's the right answer for a company if you're going to get to these hyperscales. One thing that I would call out is that you need to be thinking about DevOps. You need to be thinking about, what does it look like when you scale? If you're scaling around the world, what changes if you're deploying in just the US, or if you're in US and Europe, or US, Europe, Australia, Asia, like thinking about different regions and stuff like that. There are a ton of risks, and that's probably its own presentation on its own. And so that is something to think about, if you decide to make that change. On the buy side, so if you choose one of the providers that has a enterprise or on-prem solution, you have that flexibility now. You're able to do that sort of thing, but you then still have to take on some DevOps tasks, right? You might be installing the software on your own servers now, and you might be managing this stuff. You probably aren't doing it lightly, so it's not like you're just like, oh, I guess I'll just order the enterprise edition. You probably are doing this very knowingly, but there's still a risk because there is higher overhead. But if you don't expect high overhead with 1 million plus devices, you might be in the wrong industry. All right, so layer 11, API access. So basically, how do you access? So now you have a device, and if you remember back to layer 5, that was the command and control. So you have a cloud side talking down to a device, and it's saying, I want to change my update rate. That was the example I kept using there. And so that's the command and control. In the case of Golioth, I was talking about like DB state, and basically you're being able to push an update down to the device and say, change your update rate. Okay, that's great. But now what's on the other side of that cloud, right? So now I know that I want to change the update rate on my device from 30 to 20. But I don't want to do that from my web console. I want to actually do that from an app on a phone that I'm holding in my hand. Well, the app is actually going to do it from an API access, right? So it's going to have a API token that says, I'm allowed to talk to the cloud as well. It's going to say, I'm allowed to talk to device 22. And hey, device 22, go and change your update rate. And so then the app is talking up to the cloud through an API. And then the cloud is using LightDB to talk down to the constrained device. And that's because if you think about, well, what are the other options here? I guess another option is you could have an app talking directly to device 22, but then it would have to be validated and have all of the certificates and security in place to talk over all of these different things, assuming it's not talking over like a direct link like Bluetooth. If it was talking to the broader internet, it would have to have all of the security in place so that that app is specifically allowed to talk all the way over the internet to device 22. Most of the time, instead, you're talking to an API. So your phone, the app on your phone is talking to an REST API on your platform provider. And then the platform provider says, hey, I just got an update to go and change the update rate on device 22. I'm going to go and do that. The nice thing about this is that you can do this from multiple places. So it's an app, it's a web app, it's a, I don't know, it's another smart device talking to it. It's basically could be a lot of different inputs into the system because it's just a REST API. You could have anything that's validated. You could say, yeah, you're allowed to go and change the update rate. And so you think about building out interactive systems and having multiple control points, that can be really useful. There are different ways of actually doing this. So because it would be a push and a pull from, I'm going to just talk about from the cloud to the app. That is a push and a pull. So the app might be saying, hey, go change that update rate to the cloud. But then the cloud might also be talking back down to the app and saying, yeah, actually, I updated the rate and it's updated. And actually, here's the new chart. And so you could also be streaming the new data points, perhaps over web streams. And so basically, this is just kind of the other side of the cloud is kind of what I think about it as. So if you think about the device cloud, it talks down to the device on one side and it talks to kind of everything else on the other side, all the web enabled stuff on the other side. And so I'm going to skip the next example here. Some of the risks is that if you are doing this DIY, you're probably starting from scratch, right? You could go and write a database that basically is holding all this command and control architecture that you might have also done DIY. That's fine. But then you also have to then write an interface for that app to talk to that database. So now you're basically writing your own cloud, totally possible to do, but now you have to have interfaces out to all of the things that might also want to command and control the things on the other side of that database. And so basically it's just a scale problem, right? So you want to build this yourself, that's fine, it's totally possible, but it gets big and it gets unwieldy and you have to just kind of think about that sort of thing. When you're on the buy side, there's always the potential for API rate limiting. So if you have a lot of different clients talking over apps, you might have some rate limiting there. And then depending on how it's structured, you might not be able to say, you might say, oh, I have a really strong preference for how this data is structured, how I access each of the individual devices. How do I, drill down to the device 22, like I was talking about? You might not have any input into that. All right, last one, and we made it. We're there. So last layer is visualization, and so this is where a lot of platforms that you might see on the internet are actually visualization first. So if you see things that look really great, those are usually like visualization platforms first, and sometimes they have other stuff kind of added to them. Like I said, most of some of the ones that started in this space basically had that as a first thing, and then they've offered more down the stack. But really, this is just so that you can then show your end users, if they're not on an app, they might want to have just a visualization piece there. So they just want to be able to log in and see a chart, of the cold storage, where are all of my cold storage trucks and what is their current status, and having some kind of visualization thing that isn't a management console, but it's literally a map and it's a listing of the devices and showing 98% of your devices are fine. These two are kind of out of bounds, something like that. These are all customizable with a lot of these, but this is how a lot of your customers will often think of IoT. Some of our favorites are DataCake and Ubidots. I think these are both great platforms. They both have other management aspects as well. So like Ubidots will actually give your customers additional logins and control over what they see. So like that's a really great value add as well. So you could DIY this, of course, and this would basically be an app that would access some of the data that's there, the database that you maybe stood up yourself as well. But there's always kind of the differentiation about how you might be displaying and interacting with IoT data versus kind of more generic web data. So if you go to an Upwork and you hire some more generic web app developer there might be just kind of some translation errors in terms of what you expect to see and how you want to interface with stuff. In terms of buy, a lot of the platforms that we analyzed, actually, it kind of broke into two spaces. So it was almost like the visualization groups and then the platform groups. And usually they're partnered together. So from Goliath's perspective, we actually are partnered with Ubidots DataCake. Like I said, I really like those folks. And so because the visualization is kind of like a different set of challenges, and it is very customer facing. So just that is, it might be an additional cost there. And also another risk if you are starting from that place, is if you start with a visualization tool, that might then define who you're able to connect to as well. So just kind of thinking about that, it might be how you want to start. You might say, I really like this visualization tool, I want to build on top of that, but then there might be only certain devices or certain device platforms that work with it. So just as a thing to keep in mind. Whew, okay, we made it through the 12 layers. I'm going to take a sip of tea. So let's go through some case studies, and then we'll take some questions. I've got about 5 to 6 minutes to go through 3 case studies. And I will say one of them is completely contrived. And I apologize for that one, but I wanted to really try and offset it. It's not this one. This is actually a really good example. So Particle, I've used before. I like them. I think they're actually a really great example. They have their own hardware. So I showed the boron here, right, which is a plug-in board. So the hardware is very straightforward. You buy it from them. Device firmware, they have device OS. This is actually Particle specific firmware that's built on top of FreeRTOS, and it's got a lot of additional features in there, like monitoring and mapping and stuff like that. I think that's great. If you're using the web IDE, you can write Arduino code on top of it. It's really C++, but it's Arduino style, and so that's very updatable. They offer the Particle EtherSIM, so basically they have connectivity bundled with their platform fee as well. Their configuration state stuff, basically, if you have a variable name, you can access it from a REST API. We'll talk about this more in the REST API section as well. But this is basically you can set variables on your device and on the cloud, and then it synchronizes them. So that's basically a great example of this sort of thing. I put time series NA. This is probably not fair because I ended up changing it a little bit for others, but really it's they have capabilities, but you have to use their export function and third-party services to capture it, as far as I know. So I don't think they have time series stuff internal, but it's not super limiting. I just didn't have a good example here. Device management, they have really great console.particle.io, great for monitoring device health for individual things. They were actually our example here for device firmware update. I think they have a really great firmware update as well. Cloud interoperability, they have kind of external integrations using webhooks. And this is actually also how you might pull out data for the time series stuff. Deployment flexibility, they do not have this. So no, basically, if you wanted to then go and, as far as I know, again, is if you wanted to go and buy from Particle and then go and deploy it on your own servers, I don't think that's possible. That may be an unspecified thing, but as far as I know, that's not there. And so I don't think that's possible right now. API, they have a great REST API for interacting with their devices, and they don't have visualizations. Again, this is not a fair thing because I think on another one that I did, I actually just showed partner stuff, but it's very easy to tie into partner stuff for them. So it's just like a thing that they decided not to do. So as a summary of this one, as a case study, they're basically a pretty all-inclusive offering. I think they're one of they were one of the earliest platforms to kind of do this in a very vertical nature. I think the vertical nature is great, but where I differ and where I usually find problems with this is the when you get to the 1,000 devices, 10,000 devices, people start to kind of get a little antsy about the cost. They don't really flatten out costs at all, and so that can really just kind of lock in. And so then you're starting from that point. You have to then go and start to reset and maybe redesign things. And so if you're happy with them to keep growing, I think that's actually really great. I think they actually are a great option for small to medium businesses as well. But it's just the potential for lock-in. I think because they're so vertically integrated, there is a higher chance for lock-in. All right, so now my case study. This is the contrived case study that Mike and I came up with. So thank you, Mike. So this is the one where basically I say to someone, well, like, why aren't you, so I'm at a meetup or something, and I say, well, why aren't you building an IoT system using a platform? They're like, well, I can build that myself. And that's a very common thing. And yes, you can. And that's what we're going to try to do here. So someone takes like an ESP32 board or just an ESP32 module, and they start building with that. On the firmware side, they use Arduino Core. And basically this has embed under the hood, I believe, but basically using both the Arduino application, you can write an Arduino application, you can connect to the internet through that. You can connect to a Wi-Fi access point through there. You can set all that stuff up in your Arduino application. And then they say, okay, I'm going to go and set up my own Mosquito broker. And Mosquito is a really cool MQTT broker. MQTT is the protocol, but then there's a broker that actually kind of is multiple aspects there. If you remember from the AWS IoT, they also run MQTT, but it's kind of a more feature-rich, built-out sort of thing here. So now this is a DIY version. So maybe you're running this on a Raspberry Pi locally in your house or something like that. So you can do this sort of stuff. You basically subscribe to messages, you can publish messages, you can say, hey, device 4, go turn on your LED, that sort of thing. Now we want to start managing, like, to pull out data. So now you have this MQTT broker and it's receiving data from device 4 and it's getting updates every 20 seconds or whatever. But now you need something else to actually go and listen and say, oh, actually, whenever there's a new reading, go and pull that into a database. So you could do that with something like Node-RED, again, running on a Raspberry Pi and InfluxDB. You could run all this stuff on a Raspberry Pi locally, that sort of thing. Device management, again, this is Chris not knowing. This is not that it doesn't exist, but basically, it's because it's a DIY. It's going to be another DIY solution here. There might be some off-the-shelf solutions, like some open source software you could use for this sort of thing. And same thing for like device firmware update. You can potentially do Arduino OT. I put NA here because it's just like, it's not bundled together. It's possible to kind of script all these things together, glue them together. Interoperability, nothing. Deployment flexibility, nothing. API access, if you write it yourself, then you can maybe write something as an interface, some Python scripting to that MQTT broker. And visualization, you could, again, maybe do from Node-RED out to a visualization service. So the key thing is it's possible to do all this stuff, but it's all of the layers are local control, and there's a lot of scripting stuff here, and it would be a DevOps nightmare. That is kind of the thing. And this is before even talking about scaling. This is all I was talking about on a Raspberry Pi. I realize this is a contrived example, but this is usually what I hear about when I go to a meetup. They're like, well, I can do all this stuff. I'm like, that's great for 1 to 100 to 1,000 devices, maybe, but then 10,000, 1 million devices, it just gets really up there. All right, last one. Of course, I was going to do Golioth. Let's be honest here, folks. So we're going to do a Golioth cellular device. On the hardware side, we actually don't make any hardware at Golioth. We use Zephyr, which allows us to use a lot of different off-the-shelf hardware and basically development platforms or even modules. So the NRF 9160 is going to be the example used here. You could design that into a custom board of your own making. So the device firmware underneath is Zephyr, which is an open source real-time operating system. Then the device application is just basically the main.c and all the application level code you might be writing at the top there. For cellular devices, I'm usually choosing things like Hologram because I used to work there, and Soracom because I know the folks there, but basically any SIM provider would work there. On configuration and state, we have LightDB state. On the time series stuff, we have LightDB stream. So these are all built into the Golioth platform. Device management, that is the console, what you're seeing there. Device firmware updates, I think we do this really well. Basically, we use MCU boot on the device itself. We send entire packages down to the device using LightDB, and we're able to push that stuff back up. And then we can get new updates like that. Output streams is how we actually push to different cloud offers. We do have an extended / enterprise edition here. On the API, we have a documented API to control everything. So if you see our console, if you go to console.golioth.io, you'll see our console, you'll log in, but everything there is built on top of our own REST API. So everything you see that the console is doing, all the device management stuff, is basically a UI on top of the REST API. And finally, visualization. We don't have visualization. So that's why we partner with people like DataCake and Ubidots. No, that's the wrong. I was going to say that was weird. That was the other one. So for summary for Golioth, so we have similar features to other platforms, but what we think is we have a lot more flexibility, both deployment and for hardware, firmware, and building all this stuff up, because you actually don't even need to use Zephyr if you don't want to. We have other ways to connect to our cloud platform. I am going to take questions now. I'm not sure if I'm
Hey, Chris.
that.
Yeah,
right.
yeah, I can read them out loud for you. We have a couple
Great.
here. Thank you for the wonderful presentation.
Thanks.
2 questions here from Phil. The first one is, how does a platform like Golioth future-proof its customers against platform closure or business end of life?
That's a great question, actually. And so like with Golioth, what we do is we build on top of like really standard APIs. And so one thing that we talk about is being able to, if we were to perish tomorrow, is that, you could go and build much of what Golioth has done. But basically, we are interfacing on the web, a lot of the APIs that your device might be talking to and that Golioth's talking to on the other side. You could go and build a similar Golioth offering if you wanted to. And that's because we have really well documented, really standard API layers that we do there.
Thanks, Chris. Next question here. Do any of these layers have support for decentralized identity models, decentralized identifiers, and verified credentials, for example?
Sorry about that. Not that I know of. I usually hear someone talking about decentralized, and I'm like, oh god, they're gonna say the B word. They're gonna say it. But I don't think blockchain and IoT go together. So if that was the question, then definitely not. And again, because of the constrained device piece of it, that's really what I think about. Is that, you know, the more constraints you put onto a small little device, is the more battery power it takes. And something going through a lot of decentralization, I think that is usually a big resource hog. I'm getting some notes from Jonathan, our CEO, as well, and he said, if I can read his stuff, he says, this is a much better answer than mine. Depends on your definition of decentralized, but generally yes. Enterprise offering usually allow you to use your own PKI public key infrastructure using your own root certificates and or hardware security modules. That was way better than me just making fun of blockchain. So
Love it. Thanks for trying. Thanks, Jonathan. Thanks, Chris. Question here from Mike. Are the layers in order for decision making? Specifically, Mike's wondering, where does he start?
That's a great question. You know, so if a former consulting client of mine came to me, I think it really just comes down to the requirements they have. I mean, I know that's kind of a throwaway answer there, but it really is going to depend on, so like, for example, are you flexible in different communication methods, or are you definitely in cellular? It's like, okay, I'm in cellular. Your world has shrunk down to a subset of overall offerings. And so what I would do is try and get those very, very big high level requirements first. It's like, all right, we're only ever going to be over cellular. All right, we've shrunk down to this many offerings here. Now, what are the various things that might be out there? So, you know, I show 7 on this chart, but this is not even close to complete. You know, there might be 25 different ways, and then how many more can you remove from the process based on that? So if I'm being completely honest, I usually start from can I get anything working as a proof of concept? And then is that a valuable thing to my client? So now we have a proof of concept. They say, yes, we definitely want this cellular water level checker in the middle of the woods. That's what we definitely want. We definitely want it to be cellular. We think the battery is going to be okay, and that sort of thing. Now, is this the right cellular module, or is there something else out there? So I just feel like there's a lot of systemic level analyses you need to do first. And I'm sorry, Mike, that I didn't answer that question better.
Thanks, Chris. That's all the questions I'm seeing. We have 2 more minutes if anybody wants to unmute themselves and ask a question, or if you're more comfortable putting in the chat box, I'm happy to read it aloud for you. Chris, while we're waiting, what is the best way for someone to contact you or the Golioth team if they're interested in learning more, partnering, etc.? There you go.
Yeah, that should have been my last slide, apparently. So I'll go back to my early slide. So I'm on Twitter, Chris_Gamel. But the real easy way to get to us is Golioth.io. You can sign up on there. DevRel at Golioth.io also goes to Mike and John and myself. Direct access if you have any questions there. You know, especially if you're setting up a new system, if you're, you know, building up from scratch, like Mike was asking about, sometimes it's just about sitting down with someone. And if you do have questions about that, we're always happy to talk through it. You know, we have some answers, of course, that are going to be our answers, but sometimes it's not going to be the right fit, right? I mean, there actually are some better, some companies and some platforms offer a better fit than others. And sometimes the right fit might be starting from scratch. It's like someone saying, I'm definitely getting to 10,000 devices, and I'm definitely going to have to check in every second. It's going to have to do this, 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 and this. It's like, all right, well, maybe you need to start from the beginning and start to make sure you're stress testing your cloud system as you're going along and building a device that's going to be doing that pinging. And it's there's just a lot of potential paths out there, which is tough. I would also call out, we have a blog on Golioth.io here. And I would also call out this article by Jonathan, our CEO, who's actually on the call right now, The 5 Clouds of IoT. This is kind of a alternate way of thinking about a lot of this stuff too. So Jonathan's writing a series about the different kind of clouds that are out there. I definitely borrowed the connectivity cloud and the application cloud. Those are kind of the Soracom's of the world might be in a connectivity cloud, or the application cloud might be more like the visualization tools that I was talking about here. But just talking through these different options that are out there and what's available to you, it can be really useful.
Awesome. Thanks, Chris. We really appreciate you sharing all of this wonderful knowledge with us today. Again, thank you all for being here. This was recorded. You'll be able to find the recording on Riot's YouTube channel. I'll also share it out on the meetup group where you registered. I encourage you to reach out to Chris and the Golioth team. Thank you all for being here today. This is actually my last Lunch and Learn. So thanks. It's bittersweet, but what a great Lunch and Learn to end it on. Thanks, y'all.
Thanks,
Take
Caroline.
care.
It was really great. Thanks, guys.